So thank you, Mr. Moderator. So I'll not go into the speed contest of the shortest presentation, but I would like to thank my predecessor for giving me a little bit more time to explain to you what I want to say about G3 PLC. So my name is Nabil Sahri. I'm Business Development Director of Sagemcom. So for those who don't know us, Sagemcom is a French-based international player providing solutions, communication solutions, and connected terminals for broadband, energy, smart grids, obviously, and Internet of Things. So we are also founding member of the G3 PLC Alliance, and we are executive member. And so my speech today is on behalf of this alliance to talk to you about this wonderful technology, which is G3 PLC. So today I think you heard about G3 PLC already 2 times, one from Enedis, who explained with Bernard that it has been implemented in the French rollout for smart meters with 35 million nodes which will be deployed in coming 5 years. And the second time with my colleague from ST who introduced it as a future-proof technology for smart grid applications. So I would like to introduce this technology because in India, more specifically, power line communication is looked at a very difficult technology to use in harsh environments and difficult networks like here in India. So my speech will be more to show you that this is not true because it's being deployed actually in different parts of the world and implemented in different scenarios, and it can be actually suited for most of the applications. So someone said earlier that technology is not all of it. This is true, but without communication, you cannot achieve the modernization of grids. So first, very briefly, what is G3 PLC? G3 PLC is a communication protocol. I will not go to all the details, but it's using a physical layer, which is power line, and it comes with a MAC layer. Routing is optional, and then you can implement on top of this application. It is already implemented, for example, for metering application, but you can implement all kinds of applications. And the good thing is that it has been implemented from the start to support IPv6, which make it a technology which can be easily repackaged into the known IoT area. So the main features of this technology, I will focus only on 2. Is from the start it was built to be very robust. So it implements different error correction mechanism, which I will not go through again, but which makes it very robust. So the robustness is achieved by these different modulation schemes, but also because it's using mesh technology. So the routing is a totally mesh routing, so it enables to choose the route based on the conditions of the network. It also high data rate capability, so it can also embed security features, which is a very important feature for all the smart grid applications. So in terms of application, so you heard all the keywords, I think, through all the sessions. G3 PLC can be used in any kind of communication, either on the low voltage or the medium voltage. So it's also a very growing, the adoption of the technology is growing very fast. So you can see that 10 million nodes already are implementing G3 PLC. On the field, there's 35 different projects between pilots and bigger projects in the world. And already all the customers or all the countries who, or the utilities who trial this technology finally adopt it. So this you already heard, that it comes with different flavors. It works in all different networks, FCC band through the Senelec band in Europe or Arab band in Japan. So this technology is managed through the G3 PLC Alliance. So you can see a booth outside where you can ask questions about how to join or how to know more about this alliance. So the alliance is responsible of maintaining the technology, but also of implementing a very robust certification process, which I will talk about later, and also to do the promotion as we are doing today in front of you. So there's already more than 70 members who joined the alliance. You can see maybe a few names which you'll recognize in this list. So I'll talk more about the certification process. For any adoption of technology, you need actually a body which certifies that your technology is interoperable and it can be worked with different chips and different products coming from different vendors. So the Alliance implemented already a certification process with 2 labs, one which is LAN based in France and another one in Japan through TÜV. And once you have certified your product, you have this kind of certificates which are put on the website of the Alliance, so everyone or any customer can know that you have a solution which is truly interoperable with other vendors. So up to now, we have more than 150 certified products in only 2 years and a half, which shows again the growth of the adoption of the technology. So I'll talk now about 2 use cases which use this technology. And so Sagemcom was a pioneer to implement this technology, as I said earlier. We worked on this with NAD since 2011. So we were one of the inventor, I would say, of the technology with the Maxim Integrated, the chip manufacturer. And since then, we have trialed it in different configuration. You can see here some examples of utilities which have decided to test it. And I will focus more on the Asian environment through a project we have been doing with in Malaysia with the TNB. So it started all with in 2014 with the pilot, and this is also important for the utilities which would like to test the technologies to go through a pilot stage. So in this pilot, we implemented an AMI solution in different environments which represent the true environment of the utility through, like you can see dense area, but also rural areas. And the solution proved to work very well. The routing worked in all these different environments, so it was truly, again, a plug-and-play solution. I will skip this one, which is a use case, which is the most difficult one, but which shows that the technology could work in this kind of environment. You can see the slide later, maybe. So this gives you also the performance of the technology in terms of data rate and also in terms of speed of collection and also of implementation of the routing. So you can see that most of the information from index to load curves can be collected within seconds, actually. So this is also important, is that it's a true, I would say, operation-free solution. Once you put it on the field, after the first tweaking, you can see in the first stage, then the solution becomes stable and works all over the time without any perturbation, or except, of course, if you interrupt some signal line. So after this pilot, just to show that the utility in Malaysia decided to adopt this technology and to roll it out for the national rollout of their AMI project. Now I'll move to what have been introduced already by my colleague from ST, is to show that it can work not only on the LV network, but it can also communicate through the MV network. And through this project we did together with other partners in France, we managed to show that you can actually build an end-to-end communication platform using this communication. And the merit of this is that you are going also to simplify your management system. So the IT infrastructure could be much easier because you will have only one backbone communicating with the low voltage node, which you can monitor with a single IT platform. So this, I think, has been already mentioned. You can see the trial here in the city of Toulouse, over 35 kilometers. And you can see that also the data are flowing now from the low voltage to the medium voltage nodes using one single technology. So the use cases through this project which have been achieved are listed here. So this is, again, you can see a lot of keywords from what you heard in the session, but it's again to show that it opens door not only to AMI application, but much more, because now you can monitor the whole grid and also manage this grid using a single technology. So thank you very much for your attention.